Welcome back to the deep dive.
Yeah.
Have you ever thought about, like how we know our medications are actually safe,
Mm.
especially stuff like injections or things that go in our eyes?
It's a great question and a vital one when it comes to pharmaceuticals and, biological products in general.
Right, because we're talking about stuff that, bypasses our body's normal defenses.
Exactly. So today we are diving into the world of sterility testing. It's all about making sure those medications and products are free from any kind of harmful microbial contamination.
Okay, so we've got a lot of information on the different methods and stuff, the different ways sterility testing is actually done.
Absolutely.
Our mission today is to try to break that down,
Yep.
make it clear, make it concise, and hopefully understandable for everybody because this is pretty crucial stuff.
It really is. At its core, sterility testing is all about making absolutely sure that these products, especially things like, injectable drugs or those eye drops you mentioned, are completely free of any viable microorganisms.
Okay, so when we say viable, we mean like alive and kicking, ready to cause trouble.
Exactly. Any little bug that could potentially cause an infection, that's what we are looking for, or rather hoping not to find.
So they're not just like, looking at every single vial under a microscope or
Right.
something, right?
No, no, not quite. It would be impossible to examine every single unit. So the whole thing is based on this idea of probability and representative sampling.
Okay, so you're taking like a small portion, but making sure it represents the whole batch.
Exactly. So we take a carefully selected sample and we really put it through the ringer. We use highly sensitive tests designed to pick up even a tiny amount of contamination. Think of it like a super-powered magnifying glass for microbes.
Got it. So the information we have here talks about two main methods,
Yeah,
membrane filtration and direct inoculation.
that's right.
So let's start with that first one.
Okay.
Membrane filtration. How does that work?
So membrane filtration, it's kind of the go-to method when you're dealing with a liquid that can be filtered. And it's pretty straightforward.
Okay.
You basically pass the liquid through a special sterile filter. And this filter, it has these incredibly tiny pores, even smaller than most bacteria.
Oh, wow.
Yeah, so it's like, imagine like a super fine mesh that catches, anything bigger than those teeny tiny little microbes.
So the liquid goes through, bad stuff gets caught. Then what? What do they do with that?
So now you have this membrane, right? And it might have some microbes trapped on it.
Right.
And we need to see if anything's going to grow. So we take that membrane and we put it into a special nutrient-rich broth. It's called tryptic soy broth. We call it TSB.
TSB.
Yeah. And this stuff, it's like a feast for a lot of common bacteria and fungi, especially the ones that like oxygen. That's what we call aerobic.
Aerobic.
But we don't just stop there. We use a second broth too, just to be extra sure. It's called fluid thioglycolate medium, or FTM.
Okay, so two different broths.
Two different broths, two different environments.
Okay.
The FTM, it's great because it can grow both aerobic and anaerobic bacteria. So that covers, a wider range of potential contaminants.
Anaerobic, meaning they don't like oxygen or they can live without it.
Exactly. And then both of these broths with the membrane, they're incubated.
They're just left to sit.
They're kept at specific temperatures. The TSB is a bit cooler, kind of like room temperature. But the FTM, that's kept a little warmer, more like body temperature, for at least 2 weeks.
Okay, so we've got our membrane, could have the microbes.
Yep.
In these two different broths.
Yep.
They sit there for 2 weeks. And then how do we know if anything's grown or not?
Well, that's the easy part. We just look for cloudiness,
So if it's clear, we're good.
If it's clear, that's a pass. But if it's cloudy, well, that means something's growing in there, and that's a big red flag. That's a failed test.
Okay, so you're literally just looking at it, seeing if it's clear or if it's cloudy.
Exactly. But here's the catch. Before we even get to that point, there's a really important step we need to do. It's called the suitability test.
The suitability test.
Yeah.
Okay, what's that all about?
So this test, it basically makes sure that the medication itself, the stuff we're testing, doesn't somehow interfere with the microbe's ability to grow in the broth.
Oh.
You see, we need to be absolutely sure that if we see no growth, it's because there genuinely were no contaminants, not because the product itself, somehow prevented them from growing.
Got it. So making sure the playing field is level.
Exactly. We need to make sure our test is working properly.
Okay.
Now there are times when membrane filtration isn't an option.
Okay.
That's when we turn to our second method, direct inoculation.
Okay, so direct inoculation, when When would you use that?
This one's for products that you just can't filter. Things like, thick ointments, creams, sometimes even medical devices. So, in these cases, instead of filtering, we take a sample of the product and we add it directly to, you guessed it, those same two broths, TSB and FTM.
Okay.
Sometimes we might have to mix it up a bit first, maybe dilute it or disperse it just to make sure any potential microbes are really exposed to the broth. But the basic idea is we're creating an environment where if there are any microbes, they have everything they need to grow.
Okay. So same idea as the membrane filtration. You're just not using a filter to get the product in the broth.
Precisely. Then, just like before, it's incubation time. Same temperatures, same 2-week wait, and then that same visual check, looking for any cloudiness.
Okay, and I'm guessing that suitability test, you got to do that with this method as well, right?
You bet. Absolutely crucial, no matter which method we're using. Got to be sure the product itself isn't masking any potential contamination.
Right, right. Okay, so I remember we talked about how TSB is good for aerobic bacteria and fungi, and FTM can handle both aerobic and anaerobic bacteria.
Yeah.
Can you just remind me again why use two different ones? Like what's the point of that?
It's all about casting a wider net, really. You see, different microbes have different preferences, right?
Okay.
Some are picky. They only grow in the presence of oxygen. Those are our aerobes. Others can thrive with or without oxygen. They're the anaerobic ones.
Okay.
So by using two different types of broths, we're essentially creating two different environments. It's like setting two different traps to increase our chances of catching any potential unwelcome guests.
So it's kind of like, well, if one type of bacteria doesn't like it in this broth, well, maybe it'll grow in the other one.
Exactly. You got it.
Okay, so after that 2-week wait, what happens?
All right, so after the incubation period, it's decision time. We have 3 possible outcomes.
Okay.
The best case scenario, of course, is a pass. That means absolutely no growth in either broth. Crystal clear.
That's what we want.
Exactly. Now, if we see any growth, any cloudiness at all, that's a fail, and that triggers a whole investigation. Yeah. We need to figure out where that contamination came from. Could be the product itself. Could be an issue with the manufacturing process,
Sure.
Got to find the source and fix it.
So pass is good. Fail means more work.
Right. And then there's a third possibility. Invalid.
Invalid.
This basically means that something went wrong with the testing process itself. Maybe there was accidental contamination during the test, something that messed up the results.
Okay.
And in that case, well, you got to do the whole thing again. Retest.
Makes sense. So, I mean, this all sounds incredibly controlled and precise.
It is.
Are there like rules and regulations around all of this to make sure that it's done properly?
Absolutely. Sterility testing isn't just a good idea. It's a legal requirement.
Ugh.
Big time.
Good.
We have these big pharmacopoeias like the USP, EPJP. They all have strict guidelines on how sterility testing needs to be done. And then, of course, you have the regulatory bodies like the FDA here in the US, the EMA in Europe.
Yeah.
They're all over this, making sure companies are following the rules. And this all falls under what we call good manufacturing practices, or GMP.
GMP. So this is really, it's not just like a suggestion. It's like this is a cornerstone of how these products are made.
It is. It's all about ensuring the safety and the quality of these medications that people rely on. It's a big responsibility.
Huge responsibility.
Yeah.
Okay, so just to kind of bring it all together, what have we learned today?
Well, I think we've seen that sterility testing is way more than just, a quick glance under a microscope.
Definitely.
It's this whole intricate, highly regulated process with specific methods like filtration and inoculation.
Right.
We've got our special broths.
Yeah.
It's all designed to catch even the smallest amount of contamination.
And it's managed.
Absolutely. This is non-negotiable when it comes to pharmaceuticals and biological products.
It really is.
Yeah.
It's really amazing when you think about it.
Yeah.
We just go to the pharmacy, pick up our medications, our eye drops.
Right.
We just trust that they're safe.
Huh.
But behind the scenes, there's this whole other world of testing and procedures and these incredibly strict regulations, all designed to keep us safe.
It really makes you appreciate the level of care that goes into these products.
It really does. It makes you wonder what other kind of hidden quality checks are happening behind the scenes.
Right.
For all the products we use every day. Food, cosmetics, you name it. What's going on that we don't even know about?
A lot more than we probably realize, I'm sure.
Something to think about. Until next time on The Deep Dive.
See you then.